we were talking about permutations, which are the NPK is the number of ways there are of taking k of n things and putting them into some order. And you can think of that as a two-step process. First, you pick k of n things, and then you put those things in one of the possible orders. So how many orders are there that you can put k particular objects in? If you can distinguish between these objects, how many ways are there of ordering them? K things. A lot if k is big. Yeah, no. So we've got chalk, maybe, maybe not. I was counting on using chalk today. Goodness. I might be stymied. Okay, so we have k things. K places. How many orders can we put these things in? Well, we get to pick which one goes first. And having done that, we get to pick which one goes second from the remaining ones. And having done that, we get to pick which one goes third from the remaining ones. There's k choices for what's first, k minus 1 for what's second, k minus 2 for what's third, et cetera, on down to 1, right? And this, so by the fundamental rule of counting, since the number of choices I have at the second stage doesn't depend on what I picked at the first stage, it's always the same. The number of choices I have at the third stage doesn't depend on what I picked the first or second stage, et cetera. The total number of ways there are of putting k things into an order is k times k minus 1 times k minus 2, et cetera, which is k factorial. So there's k factorial ways of putting these things into some particular order. So we've now just thought of taking some larger set of n things, from the n, picking k, and then taking those k and putting them in some particular order. Right? And if we do that sort of all at once, if we're just going to take k of the n and put them in some order, what are our possibilities? Well, we have n choices for the thing that goes first, n minus 1 for the thing that goes second, et cetera. And we keep doing that until we have k objects lined up in a row. So the number of choices we have at the first stage is n. Having picked the first one, we have n minus 1 choices for the second, et cetera. We're doing k things in all. So these factors would look like n times n minus 1 times n minus 2, so forth, times n minus k plus 1. What's the plus 1 doing there? Is it right? Have I written down n numbers? Or have I written down k numbers? You guys need to caffeinate more before class. Should we do a special case? Okay, let's suppose that n is 10, and we're trying to put 7 of the 10 things into some order. Okay, so let's take the special case. Okay, so we would have 10 choices for the first, 9 for the second, 8 for the third, 7, 6, 5, 4. Is that 7 things? Okay, what's the last term? Yep, which is 10 minus 7 is 3 plus 1 is 4. Okay, so there are k terms in this list, n minus 1 on down to n minus k plus 1. Okay, that's why it ends there.